I'm wondering what you got for me. Egyptian cotton is out to be my lady only. I'm wondering what you got for me. Egyptian cotton is out to be my lady only. I asked you for the time. You got the damn right. Everything you do gives me butterflies. I asked you for the time. You got the damn right. Everything you do gives me butterflies. I'm wondering what you got for me. Egyptian cotton is out to be my lady only. I'm wondering what you got for me. Egyptian cotton is out to be my lady only. I asked you for the time. You got the damn right. Everything you do gives me butterflies. I'm wondering what you got for me. Egyptian cotton is out to be my lady only. I'm wondering what you got for me. Egyptian cotton is out to be my lady only.
Hello, guys in the chat. Can you hear me? Hey, Selig. So this is going to be a very different stream, more like a fun data science project that I took up in December, and this ideally should take about a week to finish, but I was very lazy and it took me a long time. So let's me tell you what we did. Okay. Hold on a second. So what I did was first I went for some data collection. Okay. In the data collection part, what I did was I took all the King of Sahara, not King of Sahara, sorry, Elo Legends replays, which is 1v1s. And let's say this was a replay. And I waited for the game at 12 minutes. So I made a hypothesis that the game winner is actually already decided at 12-minute time point. That was my hypothesis. Anything below would be too early to decide the game winner because there's so much information that's revealed right in the game, like what nation you have, what rare resources you have, what kind of eco you have, all of that info that you cannot just predict in before the game happens. So I went at 12-minute time point where everybody has reached medieval age, and I've only evaluated 1v1 games right now for simplicity. So let's see. Let me reach 12 minutes, almost there. Yeah. So when we were at the 12-minute time point, I calculated the units killed. I noted down all this information. Units killed, the unit lost, eco for both the players, ruin bonuses, rare resources, age time difference, medieval age time difference, library researches, miscellaneous researches, territory. I had to take territory because there were some games that were won by territory alone, and citizen difference. I don't know why I took that. I thought in Age of Empires citizens mean a lot, but yeah. And then I took the mouse click differences, hotkey pressed, and player speed. Only these three. So with all of this stuff, I prepared a database. Here's my database. It's a very small database, to be honest. These were what I made the model with. This is all the games up to round of 16, in Elo Legends. And hey Sam Selena, depends on where we are adding the p-value, but yeah, let me tell you the model. So first I did the data collection. This was all the part. I have just today morning I have got these three as a validation stuff. I want to show this on stream if this model can predict the Prolays versus Allen best of three accurately. I think I cast this game before, so I had it. Let's see if this model works. But anyway, so this is all the information. I couldn't collect all the information because all of this was done manually. Here's all the things that I had to manually note down for 65. It's a lot of work. I won't deny, and that's why I had to stop at 69. Anyways, actually I stopped at 65, but when I 66, but when I added the best of three, it ended up in 69. So that was my data collection. Next, we open some R Studio. I know not a lot of people here are aware of data science, and it's fine. I'll try not to go too much in detail. Here I'm going to import this data set in the R Studio. So and I'm going to just select the first minutes so that this program doesn't die on me. Okay. Also, so let me show you something. If we look at the original data set, the original data set also has the nations for each player, but we just don't have enough entries here that I can account for the nation. So I have removed this from my analysis, at least for now. I know nations are a big part of the game, but I just could not deal with nations with 66 entries only. So if we are to find out the how important nations are, we'll have to have a lot bigger data set. Anyway, so what I prepared finally was this. Without the nations, we have the results, the win and loss. The win and loss is actually for the first player mentioned. So if it's Momo versus Meliodas, the winner is referring to the first player. If it's a loss, it's also referring to the first player. So the result status is always talking about whoever the first player in the row name. Okay, and I have got all these differences, KD differences, food difference between the player at 12-minute time point, their wealth difference, their knowledge difference, their age 2 time difference, age 3 time difference, library, territory, all of this stuff. Mouse click difference, hotkey difference. Let's see which of these are actually deciding the game winner. So for this, now we come to scaling of data. What I mean with scaling, and I'll try to be as simple as possible. Scaling means that if I plot all of this data on a single graph, then I should not have values that are way on the right side of the graph or way on the left side of the graph. It's called z-score normalization that I did. That means the mean of each column is going to be the same. All the means are going to be 0. It's just so that we pack the data together. You have to do that when we look at some of these techniques. Anyway, so that was scaling the data. Then I had to come up with the best model that could predict. There's a lot of models that can do that. I'm going to start with this one particularly because it's interesting and it actually tells us an easy way to look at the data. So let me run some stuff. I'm dividing my data set into a training and testing data set. And now we come to the fun part with principal component analysis. So here's going to be the first. Yeah, here's going to be the first look. Oh man, wait, I forgot one thing. Yeah. So here we look at some very important data. This is PCA is a dimensionality reduction technique. What it does is when there are so many variables, when there are this like 23, 21, 18 total columns. Okay, if there are so many variables, how do you put them all together in 2 dimensions? This is what PCA does. And we can get some information about what is the role of each of these variables in this graph. So you can see that most of the reds are losses. Most of the losses are towards this side of the graph, and most of the wins are towards this side of the graph. So, and this is each variable, how much weight it has on the axis. So dimension 1 is PC1 and dimension 2 is PC2. These are the 2 dimensions that account for the most variance in the data. Anyway, no technical jargon. Let's just say anything here that has a negative value in PC1, anything that has a negative value in the PC1 will tell you it is required for winners, or it is something common that is the winners. So a very high metal difference, high knowledge difference, high wealth difference, these things might be obvious. High KD difference is normal. And look at this, ruin bonus. Actually, ruin bonus with a minus 0.33, it weighs more than how many rares you have, how much metal you have collected, how much knowledge, how much wealth you've got, and how much KD. So more than KD, the ruin difference has a bigger weight on who's winning. Age 2 time difference actually is not doing much. And age 3 time difference is, I think if you have a lower if you have a very high difference, you're more likely to lose the game. And other things like how many library researches you have, what kind of territory you have, citizens. Oh, look at this. Citizen difference is actually a big parameter to decide the winner. It looks like citizen difference is highest among all of those. Who would have thought that you need to have higher citizens to be winning? Hotkeys pressed also actually has some role in it, and player speed is almost 0. So what it means is player speed may not decide the winner at all. And mouse click difference, same. But hotkeys, if this is not the argument for people to start practicing their hotkeys to become better, I don't know what is. And PC2 is this dimension, the y-axis here, and I don't see any clear differences in the y-axis, so let's not talk about it. So this was just a holistic way of looking at it. We are still coming to the cool stuff. Hold on a second. So now I'm going to use this thing called 1R model or one rule. one rule model tells us just one parameter. If I had to select just one parameter to decide the winner, which would it be? Koreans close to 75% win rate. So, Sandeep, the thing is, as I said in the beginning during my data collection part, that there is just not enough data sets I have. There's just not enough data I have to figure out how nations are affecting versus each other. I do remember Hockey Star prepared a similar list where he just measured all the Nomadium 2 winners, and Koreans did have a higher win rate there. But yeah, let's look at if there was only one feature. Okay, so look at this. This is the cool stuff here. If you had to just decide the winner or loser based on one attribute, which one could it be? It says that citizen difference, just looking for the citizen difference, you can accurately measure the winner 72% of the times. KD ratio difference at 12 minutes also lets you decide the winner at 66% of the time. It's not very good, but yeah, it's assuming you only use one rule. So it's a very bad model. I don't like one rule, and I just put in there for fun. But now we're coming to the actual winner prediction. So let's see. What we're doing is, this is called artificial neural networks. It's an, well, let's see what it does. Okay, exactly. So artificial neural network, it prepares this kind of network. And I'm not going to be explaining what it does because this is not, I'm not going to be teaching data science on stream. But what it does is it takes all of these different variables, it adds some weight for each variable, it puts those weights on some nodes, and eventually it gives you either a loss or a winner for a player. Very simple, right? As in, to understand, very simple. Thing is slightly complicated. So this is the model that I have actually tried a lot of models. This is the one that worked the best. So let's see how accurately it predicts. Okay. So if I make a table, okay, this is a table for my predictions versus the actual winners that I already have on the table. So let's open this. So it says that this model is predicting a loser as a loser 5 times, and it's predicting a loser as a winner 0 times, which is very good. Then it is predicting a winner as a winner 5 times, as in all the times that I have used my testing data set, and it's falsely predicting a winner as a loser 1 time. So if we calculate the accuracy, it's about 90% accurate in predicting a winner. Okay, guys, this is pretty good model considering that we just have 65 data sets here. Now what I'm going to do is, this is the meat of the stream. If you guys came here for something, this is what it is. We are going to actually predict this data set. This is a data set that I created today morning. I haven't got to test it. So let's look at this. This is Allen versus Prolase. Okay. This is a result that I noted down by manually. Okay. So what I'm going to do is I'm going to provide this model just this data without this part. So what I'm going to provide it, the model is this part, and let's open this. If we open this part, around 7, what it means is this. So this is what the model is getting. It's not getting the information about the results. I will be asking this model to predict the winner and loser, and let's see. Okay. So here's the predictions for the model. The prediction says for the 66th game, which is game number 1, the chances for the first player losing, so number 1 means lose. I had to quantify winning and losses as 1 or 2 because this model does not work with variables that are not numbers. So it says the first player is likely to lose 85%. There's a 85% probability that the first player is going to lose. That's 1. In the second game, there's a 85% probability that this guy will lose, the first player. I'm always looking for the first player in this analysis. And in the third game, there is a 98% possibility that the first player is going to win. So let's be clear. Now let's find out who is the first player. So I'm going to open the data set again, which was Ron 1. And oh no, sorry, it was not Ron 1. This was just Ron. So let's just view Ron. So I'm looking at these last three data sets, Prolez versus Allen. It says the first player, who is Koreans, is supposed to be, so this is what I have, but it says the Korean player is supposed to lose this game. So I'm, instead of actually showing you the results, let's just go and check. The prediction says Korean player is going to lose. I'm going to open that game. I've got a lot of games sent to me. Hold on, Prolez. So this was Koreans versus the other guy was Mongols. That's confirmed. This is the same game. It was Koreans versus Mongols. Okay. And let's just fast forward this and watch. Again, the prediction says Korean player is going to lose this game based on the data that's been provided. I can vaguely remember this game. I remember Prolez did very well for Mongols for Koreans this game. Hold on, I realize I have put Ron on mute. I don't know if anybody remembers this game from the stream. It was actually a fun game. It was in the best of 3 series. Alan also did pretty well. Yeah, and Prolez almost got that cap sack. Oh wait, he did get the cap sack. He did get the cap sack in this game. So by the way, the data was collected at 12 minutes, right? This game is way over 12 minutes already. So I can't say it's too close to winning or too close to losing. Hey, Samsonella. Yeah, which variable is that? So Korean player did lose this game. The model has predicted one game correctly. Yeah, maybe that would be only applicable for games where Prolez is playing. But yeah, so the first prediction, the model says this weird model, it said that the first player is 85% chance likely to lose, which he did. And now it says the second game, again, the first player is likely to lose. I think the first player was again Prolez this time. So let's open and see if the model is correct or not. This is Egyptians versus Americans. So if you guys have not watched this replay, what do you think, who will win this? Okay, let's see. The Egyptian players got diamonds. There's so many variables, right? Diamonds, horses, salt. Actually, very good rares. I think probably he will win. On the side, sugar, peacocks. So if I had to predict, as in I always predict game winners at the beginning, or at least I say who has an edge, I would be giving my edge to Prolez this game. I don't remember the outcome of this game. The model that I've trained using the dataset has said that Prolez will lose this game. It says that there's an 85% probability Prolez will lose the game. So by the way, hold on. Just so you guys know, 12-minute points when I collected the data is way past over. And contrary to what the AI, I don't know what this model will say, Prolez is actually leading in score. Okay. Man, look at this army. Prolez actually did very well. I think he won this game. Oh, look at that. Red Fort. Damn, Alan. So this game is way past 12-minute time point. And if this one is predicted correctly, I would just say that's impressive. Although I still see now Alan is taking over the score a little bit. Yeah, I think we saw this one already. But I don't remember the winner. Police goes for Hanging Gardens. So yeah, I'm just using this as a game, as a data for testing out how accurate this thing is. I could actually also look for new games. I don't know if anybody wants to send me their standard game right now, and I can look at the 12-minute time point and see if if the model is predicting it correctly. If you guys have any 1v1 standard games, only works on 1v1 for now, because I don't know how will I train this for team games, but we can do it if. Okay, so it actually looks like Alan will win this game, and the prediction is correct so far, at least. The score difference has become huge. Alan going for industrial. Probably will capture the cap. Yep. Okay, this is the second time the model is true. It said 85% chance of losing for Prolays. He did lose this. Next one, it says there's a 99% chance that Prolays is going to win this game. Let's look at that. Let me see. Dutch versus Persians. Persian player does get horses, tobacco, and possibly silk. The Dutch player gets diamonds and papyrus. This is going to be interesting. All right, so again, the data was collected at 12 minutes time point. We are already way past that. It's just to show that it's not like I'm collecting the data at 12 minutes and the game ends at 13 minutes. So if we already know who the winner is back then. So the data was collected at a point where the winner was not decided or not even close to being decided. Man, that was a very good move by Alan. He actually messed up Prolays really big time. It's just that Prolays was already too far ahead at this point. So the third time the model is correct. Prolez did win this game after losing two back to back. And ladies and gentlemen, this is one small thing that I've made so far for predicting Rise of Nations winners in 1v1 setting only. Um, Let me see if there is another, or actually, it will take a lot of time if I have to take. But you know what? If anybody, I don't know if anybody of you wants to use this on your own games. Maybe if you have a standard 1 versus 1 game that you want to see if this model can predict the winner or not, you can let me know. I can test the same ANN model on your exam on your games. But anyway, so far we have done all of these things successfully. This is still not perfect. I'm sure we this won't be able to predict games that are not played on Sahara. Maybe I have not tested on non-Sahara games yet, and obviously it's not meant for team games so far. But what we can do in future, now this is something I'm asking for the community to help. We can expand this data set. And the way I made this data set was manual entry, but manual entry is just not feasible. We have so many replays available, and I don't think we should be manually entering this. If there is any programmer here, I'm not a programmer, by the way, not by a long shot. If any programmer here who can figure out a way to extract information from these RCX files directly, I tried, I couldn't get it to work. But if you can get information directly from RCX files so that we can make a data set like this one for thousands of games, then I can tell you we could not only get this thing going for more types of games, more types of scenarios. I was even thinking about a tool which predicts game winners in real time. So it will give you a probability as the game goes about who's winning. That tool could be really nice, and we could, and just a way, I'm going to say something very far-fetched for now, but if there is enough support from or there if there are volunteers, if there are volunteers we could, if we have enough work done, we could even get this published in a journal. Simulation master, can you predict it during game? Yeah, so yeah, this does predict in the middle of the game. So far, the way I have done it is I am collecting data collection at 12-minute time point. All the games that I have in this list, none of those games were concluded by 12 minutes. So it takes data right in the middle of the game and it predicts the winner towards the end. Yeah, Samsonella, that does look like one of the things that this model. This is the one rule. This was a different model, but it does say that citizen difference is a big deal between winners and losers. Hey, Batosai, if you can join the Discord, I'm going to open a new channel in case there is there are enough people. I'll open a new channel on the server about for this project, and if there are enough people who are volunteering to help with this, we could make this a cool tool for Rise of Nations. We could even make this, as I said, a research publication. I'd be very interested in that. We don't have to go in a high tier journal, but some journal would be cool. Samson, that's all right, man. You can just support by cheering. That's that's a good support for everybody who doesn't know programming. I was very excited with this, and the fact that it's working 90% accuracy, I am very happy, and I think we could even get this to almost 100% if we have a big enough data set for which we do need a program to extract information from RCX files. Sandeep, if you can figure out a way to get information from these RCX files, that would be great. I would even like to contact. Yeah, the thing is that I don't have a lot of time for this. I have spent enough for this project, which I am very proud of. But if somebody could contact the makers of the game to ask them how we could be extracting files, information from the RCX files, and make our own data set with every time point. Imagine we have this data, but not just for 12 minutes, but for every time point possible. So you have this kind of data for every second. That will be a huge spreadsheet, but that would provide the granularity that we need for predicting games at every time point. Yeah. And this is the part that I will be doing once we have a big enough data set. There's something called tuning model parameters. What it means is you can just improve your model through very different ways. For example, in this artificial neural network that this model has generated, I could change the number of nodes. I could change the number of nodes here, and that may increase or decrease the accuracy. I have not done that just because there's so little data set I have that I don't want to spend too much time on that. Sandeep, the input is RCX. What do you mean? Where are you inputting RCX? Yes, CSV. If you input RCX, maybe if you get a CSV file out of that or an Excel file, that would be great. That would be ideal. And Woobly actually has that. Woobly for Age of Empires, they have their own stats system where they have a database of all the Age of Empires stats. Um, I know some people have even done similar things what I've done here with Age of Empires, but it's the first time anybody's doing it for Rise of Nations. Uh, Batosai. Yeah, maybe not. I'm not sure. But if there is a way, the other way is manual. That, as I've written here, manual entry. It's just a lot of labor. I don't think if we do manual labor, first the problem is there's if there are a lot of people working on something manually, there are mistakes in entering data. Um, then I don't know how we'll find so many people who will just be manually entering data, and in the end, it's just not as much fun as it is to have a way as have an automated way to get information from the RCX files. But yeah, guys, with that, I will be ending the stream. This is the first and possibly not the last machine learning stream for Rise of Nation. Maybe one day if we figure out a way to increase this data set, we could get this to a next level. And I'll be going now. See you guys. I am going to open the Discord channel, a separate channel for the AI stuff. If you guys want to join, do join. Hey, mentalist, man, if you are just coming now, I can't explain the whole thing again, but you will have to rewatch this. I'll see you all. Bye bye.
I'm wondering what you got for me. Egyptian cutting is up to be my lady only. I'm wondering what you got for me. Egyptian cutting is up to be my lady only.